Hello friends, in the last session we have resumed the discussion of central tendencies, in which we have discussed how to determine median in respect of individual, discrete and continuous series. At the same time, we also discussed how to determine mode in respect of individual and discrete series. And we discussed also the circumstances in which the mode is considered as ill-defined mode. Now, in this part of the program, I would like to discuss first of all a problem which is based on determination of mode in respect of continuous series. After that, I would like to discuss what is geometric and harmonic mean. After that, I would like to discuss the measures of dispersion, in which I would like to discuss the limitations of central tendencies. At the same time, I would like to discuss two methods for measurement of dispersion. First is the range and second is the in-quartile and quartile deviations. Now, first of all, I would like to discuss a problem which is based on determination of mode in respect of continuous series. Now, in order to determine mode in respect of continuous series, some steps are required to be followed. The first is determine class group in which mode lies by observation of series. Now, if we closely observe the group of the class, then we can locate the class interval in which the mode lies. After that, in case of irregular distribution of frequency, grouping process is adopted to determine class group in which mode lies. Now, this is adopted only when the observation of class group is not possible. After that, we have to apply a formula, and the formula can be applied any of the three formula. The first is the Z is equal to L1 plus delta 1 is divided by delta 1 plus delta 2 and is multiplied by I. Now, in this case, we have to ignore the minus sign, but this formula is very useful in respect of ascending order. Now, second formula can be applied, and that is L2 minus delta 1 divided by delta 1 plus delta 2 and that is multiplied by I, and again we have to ignore the minus sign, but this is highly useful whenever we have descending order of the values. And third is L2 minus F0 divided by F0 minus F2 and that is multiplied by I, but this applies only when the mode does not lie in the highest frequency group. So, we have to see the situation in which the one of the formula can be applied. Now, Z here means the mode, and L1 and L2 that refers to lower limit and upper limit of the model group. F1 that refers to frequency of the model group, and F2 that is in respect of frequency of the succeeding model group, and F0 that is in respect of frequency of the preceding model group, and delta 1 is equal to the difference of F1 and F0, and delta 2 is equal to the difference of F1 and F2. Now, we discuss a problem which is based on determining mode in respect of continuous series. In this problem, we have been given the number of marks obtained by the 50 students. Now, we have got the class intervals of the marks obtained by the students 0, 5, 5, 10, 10, 15, 15, 20, 20, 25, 25, 30 and 30, 35. Now, at the same time, we have been given the number of the students who have obtained the marks. Now, 3 students have obtained the marks right from 0 but less than 5, and 10 students have obtained the marks that is ranging from 5 but less than 10. In this way, we have been given the number of students with the marks obtained by the students in this problem. Now, we have to work out the problem. Since in this question we are required to prepare the grouping table. In the first column, we have exhibited the marks obtained by the students, that is 0, 5, 5, 10, 10, 15, 15, 20, 20, 25, 25, 30, 30, 35. And in the second column, we have shown the number of the students who have obtained the marks. 3 students have obtained the marks, that is ranging from 0 to less than 5, and 10 students have obtained the marks ranging from 5 but less than 10. In this way, we have exhibited the number of students who have obtained the marks. Now, we have to have the grouping of the frequencies. In the first column, we have the grouping of 2 columns frequency. In the next column, we have the group of 3 frequencies. In this way, we have prepared the grouping of the frequency of the students. After that, we have to analyze the frequency of the students who have obtained the different marks. Now, in this way, we calculate that number of times, that is 6, that is the highest frequency who have obtained the marks ranging from 10 to 15. So, from the above analysis, we can say that mode lies in 10 to 15 class group. Now, we apply this formula L 1 plus delta 1 divided by delta 1 plus delta 2, and that is multiplied by I. Again, we have to ignore the minus sign. Now, here delta 1 is equal to F 1 minus F 0, and that is 22 minus 10, we get 12, and L 1 is the lower limit of model group, that is 10. Now, delta 2 is equal to F 1 minus F 2, that is 22 minus 14, we get 8, and I is the difference of class interval, that is 5. Now, if we substitute the values in this formula, we get Z is equal to 10 plus 12 divided by 12 plus 8, and that is multiplied by 5. In this way, we get 10 plus 60 divided by 20, or 10 plus 3, or 13 marks. So, we can say in this problem model marks obtained by the students are 13. Hello friends, we have discussed so far how to determine mode in respect of continuous series. Now, we discuss what is geometric mean. Geometric mean of a series is the nth root of the product of n values of the variables. In this case, geometric mean is calculated if we have the root of the numbers of the variables. Now, this can be explained with the help of the example. If two numbers are 3 and 27, the geometric mean will be 3 is multiplied by 27, then we get the root, and that is 81, and finally, we get 19. So, 19 is the geometric mean of the two values, say 3 and 27. If the values of the three numbers are 20, 30 and 45 respectively, then geometric mean will be calculated as follows. Geometric mean is equal to 3 and 20 is multiplied by 30, then multiplied by 40. In this way, we get 3 under root 27,000, and in this way, we calculate 3 under root 27 is multiplied by 1000, or 3 under root 3 multiplied by 3 multiplied by 3 and multiplied by 10, then again multiply by 10 and multiply by 10. In this way, we get 3 into 10, and that is equal to 30. So, 30 is the geometric mean of three values. These are 20, 30 and 45. Now, in order to calculate geometric mean, these formula are normally applied. In case of individual series, we apply this formula. Geometric mean is antilog, and that is summation of logs and divided by n. And geometric mean is the antilog of arithmetic mean of sum of logarithms. In case of discrete series, again we have to apply this formula. Geometric mean is equal to antilog summation of log x and multiply by f, and that is divided by n. In case of continuous series, we calculate the geometric mean by application of this formula. Geometric mean is equal to antilog, and that is summation of log x multiplied by f, and that is divided by n. Now, in this connection, this note is very important. Mid value of all the class group is calculated. Other steps are the same as followed in discrete series. So, we can say that in case of continuous series, we are required to calculate mid values so that we can calculate the geometric mean. Now, we discuss those circumstances in which geometric mean can be calculated. The first is to find the average percent increase in sales, production, population and business series. Or we can say that geometric mean is used whenever we are required to find out what is the average percentage of increase in sales, production, population and business series. At the same time, the geometric mean is highly useful in respect of construction of index number. At the same time, the geometric mean can also be applied in respect of when large numbers are given small weights and small numbers are given large weights. So, dear friends, we have discussed those circumstances in which geometric mean is required to be calculated. Now, we discuss what is harmonic mean. The harmonic mean is the total number of items of variable divided by the sum of reciprocals of the value of the variable. It is also called as harmonic average of the reciprocals of the values of items. So, we can say that in order to calculate harmonic mean, definitely we are required to calculate reciprocals. Otherwise, the harmonic mean cannot be calculated. Now, how to calculate reciprocals? Calculation of reciprocals takes place in this way. The reciprocal of a value is that quotient obtained by dividing one with the given values. Now, this can be well explained with the help of this example. Reciprocal of the value 2 will be 1 divided by 2. In this way, we get 0.5 of the value so far as 4 is concerned. Again, we have to divide 1 by 4, we get 0.25. In some certain situations, the reciprocals can be calculated with the help of tables. Now, use of harmonic mean. What are the areas in which harmonic mean can be calculated? The first is for calculating average speed at which a journey has been performed. Now, harmonic mean is highly useful when we are required to calculate what is the average speed at which a journey has been performed. And the second is average price at which an article has been sold out. Now, in this connection, the harmonic mean is very highly useful for a businessman so as to find out the article which has been sold out. In this case, the average price can be calculated. And third is average rate of increase in profit of a concern. Again, this is very useful for a businessman to find out what is the average rate of increase in profit of a concern. Now, so far as the formula which are required to be used in this connection, we had to apply formula in different series. So far as individual series is concerned, in this connection we have to apply this formula. Harmonic mean is equal to n divided by summation, and that is multiplied by 1 divided by x. X here means number. In the case of discrete series, again harmonic mean is equal to n divided by summation of frequency, and that is multiplied by 1 divided by x. And in case of continuous series, harmonic mean is equal to n divided by summation of f multiplied by x and divided by x. X again, that is in respect of numbers. So, this is equal to n divided by summation of frequency divided by the mid value. Now, dear friends, we start the discussion of measures of dispersions. Measures of central tendency tells about concentration of the observation around the central part of the distribution. Now, so far as we discussed how to determine central tendency in different situations, but this is useful only when we have to find out the concentration of the variables, and in this case we just find out the general information regarding the variables which are given in the table. But the use of a single value conceals many vital facts about its formation and construction. Now, sometimes what happens, we calculate central tendency, but that simply says how the values are concentrated, but it does not tell about the variations, about the dispersions, about the scatteredness of the values which are given in the table. So, this is one of the limitation of central tendency. Now, it fails to provide information regarding the scatteredness or dispersal of the values and does not enable us to study the variations and dispersal of the values. So, this is one of the limitation of the central tendency, so that it is not useful in all the cases. Now, this can be verified or this can be explained with the help of this example. Now, sometime what happens, we are calculating the same average in different, we can say, values, but so far as the construction of the tables are concerned, they are quite different and variations has taken place considerably. Now, in this example, we have been given the 3 groups of the income of the persons. Persons are A, B, C, D, E, F and G, and there are 3 groups. In the first group, the income of all the persons are the identical, and that is 10,000. But in the group second, the income is definitely quite variable. Initially, we have got 7,500 for A and B, but after that there is 10,000, 12,500 and 12,500. So, we find some variations in the income of different persons. But in the third group, we have got considerable variations in the income of persons. But it is very interesting to note that so far as the calculation of mean, median and mode is concerned, of all 3 variables, that is the same, and that is 10,000. So, if we depend on the central tendency, then definitely we will not be in a position to know the variations of the informations given in the table. So, we can say that there is a wide difference in the information and constitution of these 3 series, and that cannot be verified with the help of the central tendencies. Now, first of all, we should know what is the meaning of dispersion. Dispersion is a measure of the extent to which individual items vary. So, dispersion refers to the variations in the values which are given in the, we can say, table. The degree to which numerical data tend to spread out an average value is called the variance and dispersion of data. So, dispersion refers to the extent to which we can say variables vary, at the same time we can find out the extent to which there is dispersion of the data. Now, we discuss the methods which are used for calculating the measure of dispersions. The first is the range, the second is in-quartile range and quartile deviations, third is the mean deviations and average deviations, and fourth is the standard deviations, and finally the Lorenz curve. Now, first of all I would like to discuss the method, the range, and that is applied for measurement of the dispersion. Now, it is defined as the difference between the values of the smallest item and the value of the largest item included in the distribution. In this respect, first of all we have to find out what is the smallest value of the item, at the same time we have to find out what is the largest value of the item. Both will be we can say compared, and we have to find out the difference. So, range is equal to L minus S. L refers to the largest value of the item and S that is for smallest value of the item. So, the difference of largest value and smallest value, that is considered as the range. So, that gives an idea that how values of the table are variable and how there is scatterness in the values in the table. Now, we can also find out the coefficient of range. Coefficient of range is calculated if we divide L minus S by L plus S. Now, why should we calculate coefficient of range? Coefficient of range is calculated so as to find out the extent of scatterness, extent of dispersion in the values of the items given in the table. Now, range in continuous series, how it is calculated? The method applies for determining the range. Now, we have to complete these steps so as to find out the range in continuous series. The first is to find the difference between the upper limit of the highest wage class and the lower limit of the lowest wage class. Now, since in the case of continuous series we have got the class intervals. So, we have to find out what is the upper limit of the highest wage class, and that is compared with the lower limit of the lowest wage class. Then subtract the midpoint of the lowest wage class and midpoint of the highest wage class. So, we can say that there is one of the method this is required to be applied, and that is to calculate midpoint. Now, this is a problem which is based on determining the range. Calculate coefficient of range from the following data. Marks obtained is given 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. At the same time, number of the students have been given who have obtained the marks of we can say different class intervals, that is 8, 10, 12, 8 and 4. Now, the problem is worked out. Now, in this problem we have just calculated what is the coefficient of the range. Now, L minus S, and that is divided by L plus S, and that is equal to 60 minus 10 and 60 plus 10. In this way we get 50, that is divided by 70. So, we get 0.714. So, that is the range of this table, and that is the coefficient of range of this table. So, it is quietly definitely less than 1. So, we can say that there is less variations in the number of students who have got different marks. Now, we have to see what are the limitations of the range. Range is not based on each and every item of the distribution. As we have seen that in case of the range method, we only consider the smallest value of the item and largest value of the item. So, that does not give an idea about the variations in the values given in the table. So, range cannot tell us anything about the distribution without two extreme observations. So, this is one of the limitation of the range method. Now, this can be explained with the help of this example. Now, there are three series A, B and C, and values are given 46, 6, 46, 46 and 46 in this way, and series B that has got these values 6, 10, 6, 6, 46, 46, 46 and 46, and series C that has got value in this way 6, 6, 15, 25, 30, 32, 40 and 46. But it is very interesting to note that in all the three series range is the same 46 minus 6, that is equal to 40. So, we can say that difference is 40 in all the series, but so far as the variations in the data are concerned, that is highly considerable. So, it does not mean that the distribution are like, or we can say there is a lot of variations in the values which are given in different 3 series. So, the range does not give the exact idea about the variations of the data given in the series. So, we have to adopt the second method so as to overcome the limitations of the range method. The second method is interquartile range or quartile deviations. Now, interquartile range has been developed to overcome the limitations of the range. Now, it is calculated by deducting the value of the lower quartile from the value of the upper quartile, or we can say we have to calculate Q1 and Q3 and find the difference. These measures taken into account only middle 50% of the items. Now, what is the process to be followed so as to calculate interquartile range or quartile deviations? The first is compute the value of the lower and upper quartile, that is Q1 and Q3, deduct the value of Q1 from the value of Q3. So, in this we calculate interquartile range, that is equal to Q3 minus Q1. Now, we discuss a problem which is based on determining interquartile range. Now, weights is given for 50, 55, 67, 84, 56, 70, 75. So, these are the weight given. Now, we calculate the Q1 and Q3. Now, we discuss problem worked out. Now, we have been given weight of 15 serial number, that is 40, 45, 50. In this way, we have arranged weight indefinitely in ascending order, and on that basis we have to calculate quartile 1 and quartile 3, and quartile 1 is equal to value of 15 plus 1 divided 4, that is item 4th, and 4th item has got weight that is equal to 55. Then we calculate Q3. Q3 is value of 3 and 15 plus 1, that is multiplied by 3, and after that we divide by 4. In this way we get item of 12th, and 12th item in this series has got 82 weight. So, interquartile range is equal to Q3 minus Q1, that is equal to 82 minus 55, that is equal to 27. Now, in this problem we have calculated Q1 and Q3, and we have also found out the difference, that is equal to 82 minus 55, that is equal to 27. So, 27 is the range of dispersion or scatteredness of the weight given in this problem. Today in this part of the program, we have discussed a problem which is based on determination of mode in respect of continuous series. After that, we have discussed the geometric and harmonic mean. Then we have discussed the measures of dispersion, and we have also found out what are the limitations of the central tendencies. Now, in this part of the program, we have discussed so far 2 methods for determination or for the measurement of the dispersion scatteredness of the values, and these 2 methods that we have discussed so far, that is the range and in quartile we can say dispersion and quartile deviations. Thank you.